All right, so now we're going to do a couple examples solving inequalities using addition. Okay, so example number one, solve x minus 3 is greater than 1 and graph the solution. Okay, so the first step is I'm going to write the inequality. So I'm going to go with black. So I have x minus 3 is greater than 1. All right, step two, I'm going to use inverse operation to solve the inequality. So the inverse operation of subtraction is addition. So I'm going to add 3 to both sides. And then I'm left with x is greater than 4. Okay, because these cross each other out, and I add 4 to the other side, just like we did with the equation. All right, so now I'm going to graph the inequality. So the solution is x is greater than 4. Now I'm going to graph it. I'm going to find 4 my graph. I'm going to use an open circle because x cannot be 4. Okay, but x is greater than 4, so I'm going to shade to the right of my circle. I should have done that in red. And so my value, whatever x is going to be greater than 7. So x is greater than 4, not 7. All right, so that's how you solve an equality, just like we did with the equations, and then graphing just like we did last week. Okay, so you can always check your work. Okay, so I'm going to look at two values on both sides of my circle. I'm going to use 3 and 5. And what I'm looking at, one, is if my inequality is true, and two, if I'm shaded in the right direction. So let's write the equation up on top. Right, so I start my equation was x minus 3 is greater than 1. Go with this. X minus 3 is greater than 1. Okay, so what I'm going to do is I'm going to plug in both values on both sides of my circle and see if that equation is true. So the first one I'm plugging in is 3. All right, so instead of using x, I'm going to use the value of 3. All right, so I have 3 minus 3 is greater than 1. And if I take it 3 minus 3, so that equals 0 is greater than 1. All right, and that is not true, okay? Because 0 cannot be greater than 1. 0 is less than 1. Okay, so let's try 5. X equals 5. So instead of x, I'm going to use 5. 5 minus 3 greater than 1. And I get 2 is greater than 1. And that is true. So 3 is not true, and 5 is true. And that confirms two things. One, it confirms my inequality is true because 5 minus 3 is greater than 1. And it also makes sure that I'm shading in the right direction. So when you're checking your solution, you're not doing the inverse operation. You're going back to the original problem. You're plugging in your answer. Okay, and so before we move on to example number 2, I'm going to tell you a little bit a common mistake that a lot of students have. All right, a lot of students, and this it didn't work in this case, but a lot of students, they feel whatever side of the inequality variables on, that's the side they're going to shade it in. And that is completely 100% not true, okay? It has nothing to do with whatever side the variable is on the equality side as far as the original problem. So what I mean by that is x minus 3 is greater than 1 is the same as 1 is less than x minus 3, right? So it doesn't matter which way side the variable's on. It all depends on what the open portion of the inequality is facing. So that's for example number 2, right? So the variable's on the other side. But I'm going to follow the same exact steps. So first, I'm going to write the inequality. So 4 is less than or equal to y minus 1. Okay. Now I'm going to solve the inequality using the inverse operation. So plus 1, plus 1. All right, and then I'm left with, all right, 4 plus 1 is 5. 5 is less than or equal to y. Okay, now I'm going to graph my solution. And so, oh, and that's actually a mistake. Your symbol, your inequality symbol is never going to change from where you started, so that should always be the same. So graph the solution. I'm going to find 5. This time I'm going to use a closed circle because 5 is included. All right, and then I'm going to shade in. 5 is less than or equal to y, so y is going to be greater than 5. So I'm going to shade in to the right-hand side. All right. So 5 is less than or equal to y is my solution. Okay, and the reason I'm going back to what I said before, and I almost did it myself, I almost shaded in to the left because I didn't even look at my both sides of the expression. I looked at the way that symbol is facing, and I almost shaded it in. So when you're doing that, go back and double check and just make sure you're doing you're shading in whatever's the open end of the symbol. That's the area you're going to shade in at the variable. So let's check our solution. All right, so I'm going to use 6 and 4. Okay, so my original equation was 4 less than or equal to, less than or equal to y minus 1. All right, and I'm going to plug in place of y, I'm going to plug in 6. So I have 4 is less than or equal to 6 minus 1, which would be 5, and so that is true. All right, kind of get ahead of myself. So I do the same thing with 4. 4 less than or equal to, I'm going to plug in 4 in place of y. So 4 minus 1, which would be 3. 4 is not less than 3, so that is not true. Okay. So go ahead, do the 3 problems on your own. Once you're finished, go ahead and check out the video for the answers. All right. Good luck, guys.